Tomatoes. Juicy, delicious, and grown all over the world. But did you know that the soil and water they grow in could make or break their quality? Today, we're diving deep into how calcium helps keep tomato plants strong and what happens when salt gets in the way. How calcium keeps tomatoes firm. Calcium might sound like something just for bones, but it's absolutely essential for tomato plants. Inside the plant, calcium acts like glue, holding cells together by binding to a gel like substance called pectin. These calcium-pectin links form strong structures, kind of like egg cartons, that keep tomato cells connected and fruits firm. But here's the catch. Once calcium enters the plant through the roots, it can't move freely inside. It travels through the xylem, which moves water upward. Since fruits lose less water than leaves, they often get shortchanged on calcium. This is especially problematic during stress, like salty soil or irrigation water. What salt does to tomato plants. By 2050, nearly 40% of the world's irrigated farmland could be salt affected. Salt stress harms plants in two main ways. First, it creates osmotic stress by pulling water away from the roots. Second, sodium ions compete with calcium, pushing it out of the cell walls. That second part is crucial. Without calcium in place, tomato cells weaken. The fruit becomes soft and vulnerable to a disorder called blossom end rot, where the bottom of the tomato turns black and leathery. The experiment to understand it all. To get a clearer picture, researchers ran a 2-year experiment with Roma VF tomatoes. They used a controlled greenhouse and a special twin pot watering system to ensure consistent moisture levels. They tested 9 combinations of calcium and sodium in irrigation water and tracked things like plant growth, fruit firmness, and mineral levels. They even used high-tech tools like X-ray microscopy and ICP-MS to map calcium and potassium in tissues down to the cellular level. What they discovered. The results were striking. When sodium levels went up, water use dropped in half. That alone stunted growth. Shoot biomass dropped by over 30%, and roots lost mass too. Blossom end rot showed up in 30% of fruits under moderate salt and 43% under high salt. Even with high calcium added, BER still hit 24% of the fruit under salty conditions. Fruits also lost firmness. With no sodium stress, they were firm. But under high sodium, fruit firmness dropped by 64%. Calcium helped under mild stress, but under heavy salt, it made little difference. Calcium levels inside the fruit told a deeper story. Most calcium stayed in the outer skin, not the fleshy middle. The top of the fruit had almost 3 times more calcium than the bottom, explaining why BER always starts there. Why calcium doesn't reach the right places. So why can't calcium protect the fruit bottom where it's needed most? There are 3 key reasons. 1. As the fruit ripens, the water channels to the bottom close off. 2. Leaves outcompete fruits for calcium because they lose more water. 3. Sodium kicks calcium out of the cell walls, making the problem worse. What farmers can do about it. There are ways to fight back. Testing soil and water for sodium levels is the first step. If sodium is too high, adding gypsum or calcium chloride can help push it back out. Drip irrigation is another smart tool, delivering water and nutrients directly to the roots and avoiding buildup. Overwatering should be avoided because it washes calcium away. Farmers should also handle fruits gently during harvest, especially the bottom. And they can look into salt-tolerant varieties of tomatoes that are better at dealing with stress. A glimpse into the future. This study shows how important it is to balance calcium, sodium, and potassium in tomato farming. In the future, we could see plants bred to move calcium better, or nanofertilizers that release it directly into fruit tissue. Hydroponics might also help, since it allows full control over water and nutrient levels, perfect for salty environments. Final thoughts. Growing tomatoes isn't just about sunshine and water, it's about chemistry. With the right balance of calcium and smart management of salt, farmers can grow firmer, healthier fruits even in tough conditions. By combining research, technology, and good practices, we can protect tomato crops and ensure a steady supply for the future.